I thought of, like what I planned was to extend the syllabus. Like since we have already finished first and second module, so as I told you that we might start off with the third module. But later, then I thought that instead of that, maybe this whole time, the whatever we are getting, we can utilize in solving some more numericals and different types, which might help you in getting good marks in your Cat 1. So I have consolidated a few numericals, which I will be uploading all the solutions and everything. Not only the ones that I'm going to do today, during the class, but apart from that, there are other questions too, which I would like to submit, like upload in the course page. Alright, so you kindly go through all of them because of the time shortage, I cannot go through each and every problem. But at least I'll upload the solutions for all the questions which you can think of, which I at least think that those are important, and you can go through them. And if you have any doubt, you can ask me at any other time. Alright, so that is what I planned. So starting off with the numerical, I think the first thing that came to my mind, and I planned it, and in fact, Fatima, I think she only asked me about the same, and that is the extra numericals that I had already provided, that I have provided as you as an assignment. So I want that to be discussed for the first time because it had also four numericals and the final answers were given, but we haven't solved or I haven't solved the questions as such. So I thought of going through that first. Then I'll add a few more questions accordingly, and so that is what my thought process for the time being is. All right, so we have 24 people here. So hopefully all of you will join at some point of time. Let me just take one. How many of you are there? Okay. Yeah. So quite a few handful number of people are there. All right. So let us start off with our segment. I'll do one thing. I'll just open the question that I have given, and let us try to solve one by one, or at least I'll ask first of all of you that how you are going to approach these questions. So these are the questions which I have already submitted or uploaded for the course, and as you can understand, these are all for better understanding. So hopefully all of you have at least have seen it and have gone through it. Can someone like with here can raise your hand, like those who have attempted it for the duration of time? Maybe you have not submitted it or uploaded it, but at least have attempted on your own. Can you please raise your hand so that I can see at least whether the majority are following my orders and instructions? Okay, I can't see Manish Tripathi. I can see the hand is still raised. All right. No one else has tried, or at least have seen the question. Only one. Cynthia, okay. Cynthia, Sarah also has raised hand. Right, anyone else? Only this many hands, why? You are supposed to go through all these questions. I've been doing from my end, but you are not responding back. That's not the right way to do, right? Even if we solve it, I don't know whether it will be useful for you because you are not in a position to answer anything. But anyway, my job is to show you and to solve as much as problems as possible. So let us take the first question. That the percentage modulation of an AM wave changes from 40% to 60%. All right. So originally the power content at the carrier frequency was 800 watts. So determine the power at the carrier frequency and within each of the sidebands after the percentage modulation has risen by or risen to 60%. Okay, so this is the question. So can anyone please volunteer me in telling me how do I or how do we proceed in trying to find this particular answer? Please open your files in your system and check your own question here. Okay, guys, I need some response, right? Actually, tell me how do I proceed this question? All and everything is there in your syllabus and whatever we have discussed in that aspect only. So, can anyone tell me what is this percentage of modulation that is being mentioned over here? What does this mean? 40 to 60%? Am I audible?
So that's the M value. It changes from 40 to 60%.
Yes, correct. So, why not others are also joining in, please? Please respond that way because these are the all the questions and the types that will be coming in. Okay, so I am trying from my side, you try at least to give the answer, at least respond back. So the 40 to 60% is basically N. So what I will do is I will just start off writing over here separately. So this is the question number one, as in the numerical given. So our N is given as 0.4 and it has gone to N equal to 0.6. So this is basically what the 40 to 60% is mentioned over here. Now the question is, originally the power content at the carrier frequency was 800 watts, okay? And it is asking us to find the new carrier power as well as the sideband power at 60% modulation. So does anyone have an idea like how to go about, or what is the exact equation that we have to refer to start off for this? Do we have an equation just to hold of like give you a lead? We remember we had an equation like this: Cc plus 1 plus m square by 2. This was derived also some time back when we were discussing the power in AM modulation channel. There we had an equation something of this nature. But the problem over here is that if I want to calculate Cc, although I know m, okay, although I know m, we don't know anything about the transmitted power. Because the 800 watts which is given, this is nothing but the carrier power which is something of this nature. Alright, so the thing is, we know this equation, but the problem is we cannot use to find it for 0.6 because we don't know anything about the transmitted power or the total power, that is modulated power. Alright, so this equation is actually not justifying. So there must be some other way around, or in the question there is something given that is the beauty of this question. Because the other portion is okay. When you are calculating the USB and LSB, which both of them will be same power, that is nothing but m square by 4 into Cc. If you remember the formula, this was the formula that we had referred to. Even in the last class, when I was summarizing the concepts, I told you this equation. And please remember and make sure you make a specific note on this formula because the formulas are very easy. The questions are also very easy. Just substitute and get the answer. But if you don't know that which particular formula you are going to use at a particular case, okay, then it becomes a difficult problem. All right, so this is CESB. So the problem over here is to calculate this second part, I need to know about this carrier power. All right, which is not there at 0.6. Or do we have any lead? Okay, do we have any lead in the question that gives us an answer that what should be the carrier power at 0.6 SI? Can anyone be a little adventurous in answering this particular question? This particular part. Because if we can get the carrier power at 0.6, the rest of the things can be calculated very easily. Okay, so what should be the carrier power at 0.6 given the condition whatever we are at? Can you tell me one thing at least?
Sir,
Yes, please.
sir, could we like take 800-watt carrier power at 0.4? So using like ratio like PC1 by PC2, we can find the carrier power at 0.6.
But how you are going to do it? Okay, let me write it so that we can get the thing. So suppose PC1 by PC2, like this you are saying. So PC1 is like 800 watts. So this is X suppose. But what will you write over here? Like PC1, PC2? In
Sir,
terms of,
like we can substitute in place of like the PT because M is known.
so it like you are assuming that PT is equal to constant, right? Is it that the case? That the modulated power will remain the same even if with the change in modulation index? Because PT already you can observe that this is a function of M. So with M variation, there is ought to be some changes in the transmitted power. So you cannot keep that as a constant. Although you're like it should be PT1, PT2 like that. But you are very close to it, but it's not exactly the correct answer. The only thing is you're overlooking one thing, that the carrier power, the standalone equation that it has was something like this. The standalone equation for the carrier power PC was equal to EC square by 2R. If you go back to your previous day's lecture, you will find that this was the equation that we have used. And if you closely observe also that this segment that we are referring to, this is all constant. There is no provision of changing the amplitude of the carrier, and there is no provision of changing the resistor also. Got it? So the conclusion is that the carrier power would remain constant throughout the transmission. So this was the point actually from where the question actually came up. So power of carrier, please make a note here, power of carrier remains constant throughout the transmission. So your PC is nothing but 800 watt, and this is constant for n equal to 0.4 or n equals to 0.6. So this is the basic point from where the question actually is being given to you. Because this is the only assumption that based on whatever we have been given, that we can assume that the power of the carrier will remain constant throughout the transmission, since it is not a direct function to the modulation index. Alright. So if this is PC, then you can substitute this value of PC simply to this particular equation. Okay. And finally, you can get the value as around 72 watt. With 0.6 whole square divided by 4 into 800 watt, you will get 72 watt. And that is basically the answer which was provided over here, 72 watt. So this is the sideband power. 800 watt will always be the carrier power. Got it? So two things we have understood from this question. One is that the carrier power, and a very important observation actually, that the carrier power will remain constant. So it is not that. Already we have discussed this. Already we have discussed this with the equation. But the interpretation is what you are supposed to know and understand and give the answer. Okay, so this should trigger to your mind that the carrier power is a function of amplitude and a resistance, and nowhere it is related to the modulation index. This change is just to make you confused. This 40 to 60%, we have never used the 40% anywhere, but this is just to confuse you, nothing more than that. Okay, so read the question properly and make sure to use the correct equation, okay, in order to solve. Is there anyone having doubt with the first one, first question?
No, sir.
Anyone? All right. All
No,
right.
sir.
So I'm just keeping a little bit because I want to include as many as problem as possible. That's why a little bit hurrying. So the second question that we have is also very simple. An AM transmitter radiates 9 kilowatt of power when the carrier is unmodulated, and 10.125 kilowatt when the carrier is sinusoidally modulated. Got it? Find the modulation index. This is more set of questions. Can anyone please volunteer and tell me what I am supposed to write for this? Second question.
Sir, PT is equal to PC into 1 plus m square by 2.
1 plus m square by 2. And please tell me your name also, because I am in a screen where I can't see the person who is talking. So this is?
Sir, this is Gauri.
So equal to PC, that's correct. That's the basic equation. So you can observe that this equation, this particular equation that I have written down, this will be used multiple times. Okay, so this you should not forget, or even you should not refer a book to remember that this is an equation, because that will save a lot of. Question once again: a modulating signal an AM transmitter radiates 9 kilowatt power when the carrier is unmodulated. So that means this 9 kilowatt is nothing but the which one? This one, PT or PT is 9 kilowatt.
PC.
Yes. So unmodulated. Since this is unmodulated, so this is PC is nothing but 9 kilowatt. And the modulated power, which have been mentioned over here, the modulated power is 10.125. So that is nothing but given that PT is 10.125 kilowatt. So I'm not doing the final outcome, so you can just substitute over here. So PT by PC is 1 plus m square by 2, or m square by 2 is equal to PT by PC minus 1. M equals to 2 multiplied by PT by PT minus 1 square root. So this will be the modulation index formula that we are going to get, and this, if you calculate correctly, you should get an answer of 50% yes or that's it. That's it. That is the only easy way of finding it out. Okay, especially concerning these power equations and all those. Right? We have also done it some questions during when we studied the concept also. So you add those numericals also along with it. But remember this term, this unmodulated means it's the carrier power. Because if you are not getting it correctly, what you might end up doing is, so the total power you might mention as 9 kilowatt, and the modulated you will write as 10.125. So it will be completely wrong. All right. So that is the second question, very simple one. Then the third one that we are having, a modulating signal. This is in fact the solution is almost given here itself. A modulating signal MT is having 10 cos 2 pi 10 to the power 3 t is amplitude modulated with a carrier signal of this one, PT. Find the modulation index, carrier power, and the power required for transmitting the AM. Okay. So can anyone again volunteer why we are why we are trying to find out this modulation index using this equation? Why not the power equation was used in this case? Could we use the last, just like the last problem? We could have used this equation, right? PT equal to PC1 plus m square, because here also we have found out what is the modulation index. But can we use the same technique over here in this particular question? Anyone? Anyone?
Sir, we can use, sir, but the modulation index is unknown, so right now we can't use, sir.
No, we are supposed to find modulation index. My question is, in this particular question, the second question, we found out an equation where modulation index is related to this kind of an equation. My question is, can we use this particular equation m equals to square root 2 pt by pt in minus 1 for the third question also. Can we use that? Because here also it is asking to find the modulation index.
Sir, but we don't know PC and PT yet, right?
That is the answer I was talking about. That this is a different question in which you are observing that the approach towards finding modulation index is different, because in this particular question there is no provision given with respect to the carrier power or even the transmitted power. In fact, that is what you are supposed to find out over here. Okay. So carrier power and AM wave. So this is basically PT and PC is what they are asking you to find. Okay, so that's why don't mug up the thing. It's just that based on the given numerical, you have to improvise based on the formula that you already know. Alright, so that is the main point of my interest. So you can see here itself the solution is almost given. So we knew that the modulation index is basically, there is another way of representing modulation index, and that is nothing but the ratio of amplitude of the modulating signal to that of the carrier signal. So Vm by Vc is nothing but this. So Vm, what is Vm? Vm is 10 divided by Vc, which is the amplitude of the carrier, which is 50. So 10 by 50 you will get around 0.2 as an option. Alright, so this is basically what we are observing with respect to the modulation index. Now naturally we can go back to our formula for the carrier power and all. So let me go back to my writing pad. So the third question, so we already got m is equal to 0.2 almost. So this is, I'm not solving again. Now this you might have a question that, sir, if I want to use the equation E square or EC square by 2R, this is the equation that I mentioned just right now, just a minute back, about the genetic equation for the carrier power. The question is, this R is unknown. Although we have a magnitude which is 50, okay, 2 is fine, but we don't know about R. So what do we assume when there is no R? So just make a note that if there is no provision of R is provided in the question, consider the resistance to be 1 ohm. Okay, consider the resistance to be 1 ohm. So unity resistance, that's the one that we are considering. If it is not mentioned, if it is mentioned, you have to substitute accordingly and you to go about solving it. So this, if you substitute, you are getting around 1250 watts of the carrier power. Alright, and similarly the same equation of PT equals to PC 1 plus m square by 2 can be used. Okay, now you know m, now you know PC. The final outcome is around 12.75 watt as the transmitted, the full power or the final power, which is the power required for transmitting the signal. Alright, so in all these three questions, you can observe that they although they are going through or they're being done using the very similar portion of the question, that is the power relationship and all, but each of the questions has a different flavor to it. Okay, so that's the observation, that please read the question carefully and based on that you answer. Okay. Now coming to another interesting question which was here, which was given as the fourth one, that is if the equation of the amplitude wave is given by this. Okay. Now question is, find the carrier frequency, okay, carrier power, the total sideband power and the bandwidth of AM wave. Alright. So in this also, I would like to have an answer from someone who has not answered till now, that how do I approach this particular question. The question is to find the carrier power. How do I know? How do I go about knowing it? Because we already are having different techniques of finding the carrier power. We also have a process of finding out what is modulation index. So in this case, suppose I want to find out, then is there a provision or is there a way we can actually solve it for our purpose? Okay. Can anyone, or should all of you please note down or at least can observe over here, because this equation that is given, this is a specific format if you can observe. 21 plus 0.8 cos of 2 pi something multiplied by cos of this. This is very much similar to what what I have written over here. This portion that you're looking at, that is, I'll write it over here for, because I can't edit in PDF, so I'll go here. This is the fourth question. So if you observe that this equation ST equal to EC1 plus M cos 2 pi FMT multiplied by cos omega T 2 pi omega T. If you remember, this is the equation for, can anyone tell me what is this for? Where we have used this particular equation format? Anyone? Where have we used this particular format of output generation?
Sir, in modulator?
In modulator, but with this kind of because we have discussed the ESPST, we have used the AM modulator, we have used the SLC modulator. So ideally, what is like this pattern of equation, which particular modulation you are referring to, or how we are looking at it? If you again, I think there is a lag in the process you are like you are going through the subject, like you are not really going through the topics as such. I think so that's why, because this is a general equation for AM. This is the first few days after our starting of the semester when we were doing the AM modulation. Go back to the previous days lectures, like class number 3, 4, like that. You will find that we have derived this equation when the AM modulation, that what exactly is AM modulation, where there is a carrier which is holding up or which is carrying the message from one point to another. The equation can be given by of this region. We have derived that also in the class as well. So basically, this equation resemblance, the one that is given, the provided to us as 21 plus 0.8 cos of 2 pi into 10 to the power 3t cos of 2 pi, or rather cos of 4 pi, basically 4 pi into 10 to the power 5t, like that. So you can observe that this is a clear reference to this particular equation. Hence, we can easily say by observation that EC is nothing but 20, M is nothing but 0.8, Fm is nothing but 10 to the power 3, okay, 10 to the power 3, this should be hertz in fact, okay, and Fc also we can write as 2 into 10 to the power 3 hertz. Why Fc is 2 into 10 to the power hertz? Can anyone tell me? This is 2 pi Fc, right? This is Fc, 2 pi Fc. So basically, we have, this is 2 into 2 pi. So that 2 is 2 into 10 to the power 5. Okay, so that is what I'm trying to write. So it is 200. Would write 200 kilohertz. Maybe I'll do one thing. I'll write it as 1 kilohertz directly, and this can be this is 5 in fact. So this is 200 kilohertz. Okay, so these are the information that is completely observable just from the equation. You don't need to calculate anything. Now, if you go back here, it becomes really easy. So you can see that first question is PC. Okay, again, assuming that R equals to 1. So we can substitute directly to that equation as I already had pointed out. So PC is equal to EC square by 2R. Okay, now EC is 20 square by 2. This is 400 by 2 or 200 watt, that is the power case. Okay, and similarly the others can be also found out as 64 watt as well as. Okay. Now second question is total sideband power. Now if you observe that we have already given an equation where it was something like this, P USB, P USB equals to P SSB equals to M square by 4 into PC. So now you know PC and M also is known. So 0.8 whole square divided by 4 into 200. So this is what we are getting out of the final result with respect to 32 watt almost. This is what the answer we are getting. But this is for USB as well as for LSB. But the question here is, this is where you will make a mistake. The question here is total band power. It's not about only one side band power. It's the total band power. So the total band power should be total sideband power is nothing but 2 into 32, which is 64. Correct? So this is where little imagination, like it's the reading of the question is very important. And finally, if you observe here, the AM wave, bandwidth of the AM wave, which we already know that bandwidth. Can anyone tell me what is the bandwidth of an AM? What is the bandwidth of an AM wave?
2 FM.
2 FM, correct. 2 into FM, and FM is already provided as 1 kilohertz and something like that. So basically, your bandwidth is 2 kilohertz. That's clear. Alright. So now suppose you are asked to find out that what should be, suppose this part is SMFC that you have mentioned over here. I have not, it is not given in the question, nor it is asking you to find. But suppose in the question we modify it in that way, that also find the carrier frequency and the modulating of the baseband frequency which has been used in this particular modulator. So you can easily understood the line, the equation, and you can decipher that these are the frequency for modulating signal as well as for the carrier. Alright, so these are the 4 questions which I had given for your just for your own refreshing your mind and to go about solving this on your with your like on your own, so that the equation you are familiarized with. So that was the very reason why I have given this particular question. So those who have done it, it's really good. And I think I have mentioned one of the names, Gauri Girish. Are you there, Gauri? Yeah, Gauri Girish Nair. Yeah.
Yes, sir.
So yeah, I think you all should give her a round of applause because she actually has submitted and she got all the questions correctly. Okay, and she did it excellently. So she actually was the one, the paper that I have returned back in fact. So well done, Gauri, and it was really nice to go through the paper because or the solution how you have made it. So I hope the others will also be doing it now since the solutions and everything is almost done. I think the requirement is little less, but at least still what you can do is that for that you can take still the question, okay, similar type of question from the one that I am going to upload, and you can check on your own that whether you are able to solve it or not. Then later you can check the solutions how it has been done, because the questions will all be almost the same, very similar here and there, and the equations are also very limited. So just make sure that you understand that. Okay. So this is one part that I thought of telling you. The next question that I think I would prefer to attempt also, that is given by something of this nature. This I will solve it over here itself. So this is again some additional numerical as I was trying to point out to you. So this I won't be doing it. You please tell me how do I proceed in solving this particular question, which is given as following: that the antenna current of an AM transmitter, okay, is around 8 ampere. Okay, and but it increases to 9 amps when the carrier is modulated by a sinusoid wave. All right. So find the percentage of modulation. Determine the current, antenna current, when the percentage of modulation changes to 0.5. There is 2 missing over here. This will be a 2 over here. or maybe I'll do that. So can anyone please guide me what kind of formula you are going to apply to and how you are going to proceed? Please tell me. So this is the question again. I think very similar kind of question. I solved it in the class also. I told you that it's a special case of the power calculation or the index calculation also. Does anyone remember what was the equation and why? How do I proceed this? Anyone?
Sir, m square equal to 2 into IT square by IC square minus 1.
So in general, we will start off from here. Okay, that we know that IT is equal to IC square root of 1 plus m square by 2. This is where it all starts. It's very similar looking to that of the PT and PC equation that we were referring just right now, few moments back. So from here you can refer to which who told the equation?
Sir, Satvik.
Satvik. So m was given by this also. I think we did it in the class itself. So this was given by IT by IC whole square minus 1. Okay, something like this. It was mentioned. Now in this case, your IT is 9 amps. Your IT is 8 amps. Okay, so IT is given by 9 amps because this is the increases to 9 amps, and that too when it is, but it when it is modulated. So after modulation, we are getting, so IT is 9 amps. Carrier, which is unmodulated one, that is 8 amps. Okay, so you can substitute here and you can get the corresponding answer. I'm not trying to do that to save time a little bit. So that is the M, and now with that determine the antenna current when the percentage modulation changes to 0.5. So the same way you can find out antenna current. So IT is what we are trying to find out now, which is IC will be the same, the one that you are getting over here. IC already is given, so 8 amps. Okay, so square root of 1 plus 0.5 whole square by 2. So whatever you are getting, that will be the final answer. Okay, so this is about the question that is different again with respect to the other 3 or other 4 that we have solved today. And hopefully you can finish it off. I don't have the final answers, I think, for this. So you can just kindly do it and keep it with you on the answer. Alright, so this is one of the questions, one of the type of a question. The other question again, I think this is also very similar, but I thought of just telling you because it's little different, or whatever you call them. So the question is, the amplitude modulated amplifier provides an output of 106 watts at 100% modulation. So this is the maximum that is possible. Okay, because 100% modulation in a way it means that we have n equals to 1. Remember, this is again a summary that n should vary between 0 to 1. Okay, and it can't be greater than 1 until it can be equal. That is the maximum value that is supposed to get, because otherwise there will be distortion. Okay, so that is why we are eliminating the chances of that. So at n equals to 1, they are getting 106 watt, and the internal loss is also 20 watt. Now, the question is to find the unmodulated carrier power. Alright, so here the total power is actually provided to us. We have to find out what is PC. So again, the same formula is what we are going to use. PT equals to PC 1 plus m square by 2. So you can observe that almost for 80% of the numerical, whatever we have solved so far, this energy of the power equation is actually being used multiple times. Right? Now, can anyone tell me what is the value of PC that we need to consider? What will be the value of PC? Given the specification, can anyone please tell me what is the value of PC? Is there anywhere given the carrier power? Is it given at any point? or is, oh, okay, carrier power is what we have to find out. So ideally, I was making a mistake. PT is equal to PT 1 plus n square by 2. Fine. So this is what we are looking at. Now, what do I can consider with respect to PT? What we should consider with respect to PT? What is the total power given? Guys, please respond. What is the total power provided to us in the equation?
Sir, is it 106 minus 20?
I will hope get this answer. So this total power, you can observe, actually she was right in a way that attempt was, the concept was wrong, but the attempt was correct. So this PT is the total transmitted power we are looking at, right? So here if you observe that the output is 106 watt, but along with that there is an internal loss of 20 watts. So it means that 106 plus the 20 watts, this was supposed to be the total power which was available. Understood? That is why this question is little different. Other than that, nothing is there. Same. So 106 watt is what we are observing at the output. But that we are getting after the 20 watt of power which got out of the whole system or the internal loss, which is lost due to different losses. So the total power in calculation we need to take it as 106 plus 20, and this is 1 plus half. Okay, so the overall calculation will give us a result of sideband carrier power of around 84 watts. Alright, and similarly we can find out what is the USB and LSB. The ESB and LSB are the same. Okay, and that is equal to PT n square. Sideband power, I think we have discussed right now, right? Sideband power n square by 4. Yeah, n square by 4 into PT. So that we can substitute over here, n square by 4 into PT. All the details are provided to us. We can substitute and we can get the desired answer. Okay. So this is another different way of approaching. So let us take quickly the last question because I think we are running short of time. So this is another question which is a little difficult or different to be honest. And the question is, a sinusoidal carrier of this nature is amplitude modulated by a sinusoidal voltage of this nature. Both the nature of the voltages are given up to a modulation depth of 50%. So now we know that M is equal to 0.5 modulation index. Calculate the frequency and amplitude of each sideband and RMS voltage of the modulated carrier. Okay, so this, if you observe that this is something different to that of what we have observed for some time now, because in this case the power, okay, needs to be calculated. There is no power that needs to be calculated, but calculate the frequency and amplitude of the sideband. So that is what the idea is. So if you observe that frequency, please make a note of this. So USB frequency that was equal to Fc plus Fn. Correct. So now we know how do I read this. So this is my sinusoidal carrier. So ideally my Fc is 10 to the power 5 because this is the carrier we are looking at. So your Fc is 10 to the power 5, and again this is where I would also I want you to remember that the carrier frequency will always be greater than the modulating frequency or the baseband frequency. And this is one of the indicators whether you are choosing it correctly or not. So make sure you do that. So this plus 10 to the power 3, so this becomes the total frequency that is we are available with, and that will be coming around 1.01 into 10 to the power 5 hertz. Similarly, LSB frequency that is equal to Fc minus Fm. Okay, so 10 to the power 5 minus 10 to the power 3 minus 10 to the power 3. So this is around 9.9 into 10 to the power 4. Alright, so this is how the two frequencies that we have obtained. Now because that is the question we asked, amplitude of each side wave. Okay. Now coming to the RMS voltage. The RMS part we can calculate using the formula that we already know, that is RMS voltage. This also we had done actually previously. VC by square root 2. Okay, so RMS voltage of the carrier, if you consider RMS voltage of the modulated carrier. Okay, so this is the RMS voltage of the carrier itself. Okay, only the carrier. This will be around 70.71 volts. Okay, and the modulating signal, modulating voltage, that is RMS once again, that is equal to Vm by square root 2. Okay, so Vm is equal to 50, so that will be equal to around 35.36 volts. So these are the individual RMS voltage of the carrier and the modulating. Now remember, in case of an AM modulation, we are basically adding up the two things. So your total RMS will be something like square root of 70.71 whole square plus 35.36 whole square. Please make a note of this. This is the total RMS is given by the square root of the individual voltages and their addition. Okay, so that is the total RMS, and we can get the answer as 79.06. Okay, this is at this many volts. All right, so I think we are running out of time already. So these are the type of questions. There are very different other questions also, and very similar type also. So whatever I thought of as a question which are important for you, okay, with all the solutions I have uploaded, I'm going to upload the answers and the details in the course page. So kindly look into those questions and their answers. Even the question that I solved last, that is the last 3 questions that I solved, that also will be there in the solution set also. So kindly look into the recording, look into the detail of that page, okay, the course page, and you will get the answer. And even after that, if you have doubts, you can just tell me before the exam or like anytime. All right, no problem from that. Okay, so that is it for today, and we'll come back after the CAT exam is over. All right, Apur, any doubt you have, Apur?
No, sir, no, sir.
So hopefully you will do well. Okay, let me tell you the pattern of it. As I said already, you can. I think you all can. Let me do one thing. First of all, I'll stop recording the session. This is all done.